Hey guys, welcome to day 31. This will hopefully be a short video here. We're looking at the process of sketching F and F prime graphs based on being given the other one. Okay, so this takes a little bit of brain power, and remember, it's just a sketch. It's not something that has to be perfect. Okay, so when I take a look at this graph here I have an F graph. What I want to do is sketch on the same axes here. I want to sketch a possible graph for F prime. Okay, and the process of doing this can be very helpful for deepening your understanding of what's going on here. Okay, so let's take a look. When I look at this, this is now a graph of F. Again, it's very important to know which graph you're looking at. We're looking at a graph of F. Couple of things that I like to notice about this F graph is that this F graph has a local max and a local min. I'm going to identify those points. I don't see any other local maxes or local mins. I don't see any other places where F prime would have a slope of 0. Right? Those are my critical points of F. So when I go to make an F prime graph, I know that local maxes on F prime are when F prime switches from plus to minus. A local min is when F prime switches from minus to plus. Those are things we know that we've worked on recently. So what I want to think about is I'm going to sketch my F prime graph in red. But pay attention, because the two examples I'm going to do today, the first example is sketching F prime based on F. The second problem will be sketching F based on F prime. Okay? They're done differently, but it's kind of the same process. We just have to think forwards and think backwards. Okay, so the first thing I want to think about there is I am sketching F prime, okay? And I like to figure out my zeros of F prime first. That local max and that local min of F there, those will be places where F prime equals 0. So I'm going to go ahead and plot those zeros first. Now, I know since it's a local max, my F prime graph is going to have to switch from plus to minus. I can also think about that in terms of, okay, to the left of the red dot, my F graph, that black line there, that black line is increasing the entire time. Looking at it left to right, that graph is increasing. So that means F prime should be positive left of the red dot. And it seems like it's, right? It seems like it's pretty steep towards the end, and it keeps flattening out. By the time it hits that local max, that's when it's hitting 0. That's when F prime is hitting 0. So I think F prime might look something like this. I have a higher F prime value here because my slope of my tangent line is steeper here. Right here I have a pretty low F prime value because this tangent line isn't as steep, right? All those tangent lines are positive, but they keep getting closer and closer to 0. Okay? Now, from the 0 on the left to the 0 on the right, that stretch of the graph between the local max and the local min, I notice on that stretch here, that stretch of graph, F is decreasing the whole time. That means my F prime graph should be negative the whole time. Okay, I'm going to get that little annotation out of there real quick. Okay. So, but this stretch right here, F is decreasing, so my F prime graph should be negative. I notice that it's decreasing the most steeply right here, so that should be my lowest point down here. Okay, so it might look something like this. Okay. Now from the second zero there, where I'm at in my graph, from here on out, f increases the entire time. That means my f prime graph that I draw should be positive the entire time. So I'm just going to continue this thing out. And the farther I go to the right, the steeper my line gets. So my f prime graph should be positive and should be increasing. There's a pretty rough sketch of my f prime graph. The other thing I want you to notice is this black graph here. That looks like a cubic graph, right? That looks like some kind of x cubed plus something, right? And look at my red graph here. This looks like a quadratic. This looks like x squared, which should make sense conceptually, because if I had a cubic function and I did the derivative, it should be a quadratic function. So that should kind of match what's going on here, right? If we want to think a little bit more meta about that. Okay? All right, now let's do it the other way. I'm going to start with an f prime graph, and I'm going to try and sketch an f graph. Okay, so here's an f prime graph. This is a little bit more difficult to do because we don't know exactly where to place the f graph. Okay, but what we can do here is we can place it anywhere we want. Okay, what I like to do is I like to analyze the critical points of f prime to get an idea of what's going to be happening on f. This is more like what we were doing today in class. So I'm going to look at the 3 zeros here. Now after today, you should be able to identify what's going to be happening on f based on those graphs, right? When I take a look at that leftmost zero, the one over here, what I notice is f prime is switching from a negative value to a positive value. What that tells me is anytime f prime switches negative to positive, that means f has a local min. So I know my graph needs to have a local min here. Similarly, the rightmost point, I know that this is a local max. And again, I should add in of f. And I know that this is going to be a neither point. And I know that those neither points oftentimes look like terrace points. So my f graph, now I can start it up here, or I can start it down here. Okay, I'm going to start it maybe right here. It doesn't really matter. Okay, I'm going to start it right there, but I know I have to get a local min at that zero. I know from here to here, I must be having a local min on my graph right here. I also know, since f prime was negative for that whole region, I know my f graph had to be decreasing for that whole region. Now, it could be decreasing in the positive part of the graph or decreasing in the negative part of the graph. That doesn't matter. I just know that the graph had to decrease that whole time. Okay, for the next stretch here, from left dot to middle dot, I know that my function f must increase that whole time because f prime is positive that whole time. Okay? But it's going to start to flatten out by that second dot. So I'm going to increase, but I'm going to start flattening out right here at that zero. But instead of that being a local min, where I would just continue this black graph to go down here, my graph actually starts increasing again. So right from here, I'm going to pick up and keep increasing this graph, and I'm going to create a terrace point. And I'm going to keep increasing until I reach this part right here. And now once I get to the right of the rightmost dot, since f prime now becomes negative, my f graph must now start decreasing. There's a possible f graph. Now, for some people, they have a hard time, they have an easy time going one of the directions and a hard time going the other. Okay? Some people struggle with both. Usually we struggle a little bit on one of these, okay? But when I look at this graph, when I step back and look at my f graph, I should see a local min at that left dot, I should see a local max at the right dot, and I should see a neither point in the middle. Anywhere f prime is positive, I should see f increasing. Anytime f prime is negative, I should see f decreasing. And the farther away f prime is from the axis, the steeper the line should be, either positive or negative. Okay? Again, this is a little wacky to do, but we'll practice it tomorrow and we'll start to get used to it. All right, that's it for today. I'll see you guys tomorrow. 2 chains, bye.